so we're going to talk about arithmetic sequences. Arithmetic sequences always differ by a common difference. So with common difference, we're talking here about adding or subtracting. So from one term to another, it's always adding the same number or subtracting the same number every single time. So if we're looking at this first sequence, first we're going to talk about recursive equations, and then we'll talk about explicit. So with recursive equations, we always start with the first term, or a sub n, or a sub 1. A sub 1 means the first term in the sequence. So in this sequence, what is the first term? The first term is 11. Okay? The nth term in a recursive formula is always based on the previous term. So the term, if I'm trying to find a sub n, or some number n term, to find that term, I have to take the last term. So the term right before a sub n would be a sub n minus 1, because that would be the term right before. And then I'm going to add my d. So in this case, what would the d be? Well, from 11 to 7, we are subtracting 4. From 7 to 3, we are subtracting 4. So the d in that case would be minus 4. So in this case, the equation for it would be a sub 1 equals 11, a sub n equals a sub 1 n minus 1 minus 4. And there is your recursive formula. So to find an explicit formula, the explicit formula for sequences is a sub n equals a sub 1 plus n minus 1 times d. I have a little wrap there that I use to remember it. A sub n equals a sub 1 plus n minus 1 times d. Okay, so to find these things, first we don't know what the term is. The first term in the sequence we talked about already is 11 plus n minus 1 times, and then my d we talked about is that minus 4. So if I were to make a generalized equation for this, I can do some reducing here. So I can distribute that. So we'd have 11 plus negative 4n plus 4, because negative 4 times n is negative 4n, negative 4 times negative 1 is positive 4. And then I would find my terms that are like. So my formula, if I were to write a formula, an explicit formula, would be a sub n equals negative 4n plus 15. So now I'm going to take that, it says, and then find the 10th term. So I'm going to take this, and I'm going to plug in 10 anytime I see an n. So I took this exact same equation, and when I saw an n, I plugged in a 10. So now I'm going to do that math. So a sub 10 equals negative 40 plus 15. So the 10th term is negative 25. And I could find that out with my recursive equation too, but the problem with the recursive is you always have to go back to find the previous term in order to get the current term. So like, if I'm trying to find a sub 2, a sub 1 would be 11, so it would be a sub 2 equals 11 minus 4, which is 7. With recursive again, if I'm trying to find the third term, it would be 7 minus 4 is 11. The next one will be 3. 3 minus 4 is negative 1. And we'd have to do that over and over and over again to get to the 10th term. That's why explicit formulas are so nice, because you can just plug in whatever term you're trying to find. All right, hope that you can tell the difference now between a recursive equation and an explicit one for an arithmetic sequence.